Hello everyone, and welcome to another video in my channel. In this video, we are given a very nice Olympiad challenge to solve. We are given root 2 plus 1 all raised to power x plus root 2 minus 1 all raised to power x is equal to 34. We need to find the value of x. What are we going to do to solve this problem? When we examine the left-hand side of the problem, we will see that they are surdic expressions, and at the same time, they are conjugates. This information will help us to make a very nice substitution which will aid the solution of this problem. For example, if we multiply the conjugates, that is root 2 plus 1, by root 2 minus 1, we are going to get 1. And if we divide both sides of the expression by root 2 plus 1, we have root 2 minus 1 is equal to 1 over root 2 plus 1. So what I will do is to substitute root 2 minus 1 with 1 over root 2 plus 1 in the original question. Root 2 plus 1 all raised to power x plus 1 over root 2 plus 1 all raised to power x is equal to 34. Now, if I apply this property of indices, which is a divided by b all raised to power n, it can be written as a raised to power n over b raised to power n. I will apply this property here. That becomes root 2 plus 1 all raised to power x plus 1 to power x over root 2 plus 1 all to power x is equal to 34. 1 to power x is still 1. So I have root 2 plus 1 all to power x plus 1 over root 2 plus 1 to power x is equal to 34. Now, I need to make another substitution. That is, I will let y equals to root 2 plus 1 all to power x. So here I have y plus 1 over y is equal to 34. If I multiply through by y, I'm going to get y squared plus 1 is equal to 34y. Now, this is a quadratic expression. This is a quadratic equation rather. Let me now rewrite it in standard form. So I have y squared minus 34y plus 1 is equal to 0. I will not be able to factorize this quadratic expression, which is in the left-hand side. Therefore, I'm going to apply the formula method. So y equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Where a is 1, that is 1 here, and b is minus 34, which is this one, and c is plus 1, which is this one. So putting the values of a, b, and c in the equation, I have y equals to minus 34 plus or minus the square root of minus 34 all squared minus 4 times 1 times 1 all raised to power 2 times 1. So if I simplify further, I have y equals to plus or minus. Now I have 34 squared, that is minus 34 times minus 34 is still 34 squared minus 4 all over 2. I can use my calculator to punch this thing and then find the value of y. But what if a case where we are not required to use calculators, as many exams will do? How are we going to find the value of y and then the value of x? First, I'm going to rewrite 4 as 2 to power 2. So I have y is equal to 34 plus or minus the square root of 34 squared minus 2 to power 2 all over 2. Now, the expression in the square root is difference of two squares. Let us remember a squared minus b squared can be written as a plus b and a minus b. When we multiply it, we'll get this. So y is equal to 34 plus or minus. Now applying this difference of two squares here, I have 34 plus 2 times 34 minus 2 all raised to power 2. So now, let us add 34 and 2 to get 36, and 34 minus 2 to get 32. So I have y equals to 34 plus or minus the square root of 36 times 32 all over 2. Now y will now be 34 plus or minus 36 can be written as 2 times 18, and 32 can be written as 2 times 16 all over 2. Y equals to 34 plus or minus. Now 2 times 2 is 4, so I have 4 times 18 times 16 all raised to the power 2. The square root of 4 is 2, so y equals to 34 plus or minus 2, the square root of 18 times 16 all raised to the power 2. Then simplifying further, y equals to 30. Now 34 is 17 times 2, so this is 2 times 17. I'm factorizing 2 out, plus or minus, then the square root of 18 times 16 all raised to the power 2, where these 2 will cancel these 2. So I have y equals to 17 plus or minus the square root of 18 times 16. 18 is 9 times 2, and 9 is 3 raised to the power 2. 16 is 4 raised to the power 2. So I have y equals to 17 plus or minus. I was saying 18 is 9 times 2, that is 3 raised to the power 2 times 2. Then times 16 is 4 raised to the power 2. Y equals to 17 plus or minus. This is 3, that is 3 squared. The square root of 3 squared, which is 9, is 3. And then times 4 root 2. So I have y equals to 17 plus or minus 12 root 2. Now let's recall that y is equal to the square root of 2 plus 1 all raised to the power x. That implies square root of 2 plus 1 all raised to the power x is equal to 17 plus or minus 12 root 2. So we have two cases here. In the first case, root 2 plus 1 all raised to the power x is equal to 17 plus 12 root 2. That is case 1. And then root 2 plus 1 all raised to the power x is equal to 17 minus 12 root 2, which is case 2. Let us now solve case 1 first. I am going to rewrite the expression in the right hand side to be exactly in the form of the expression in the left hand side. So root 2 plus 1 all raised to the power x is equal to 17 is 9 plus 8. Then plus 12 is 4 times 3. That is 3 times 2 times 2 raised to the power 2. Good. Now, 9 is 3 raised to the power 2, and 8 can be written as 2 raised to the power 2 all squared, because 2 times 2 is 4, and root 2 times root 2 is 2. 2 times 4 is 8. So I'll write this 8 as 2 root 2 all raised to the power 2 plus, now this is 2 times 3 times 2 root 2. Do we see that this is taking the form of a perfect square? If I have a plus b all raised to the power 2, I'll have a squared plus 2ab plus b squared. So this is now taking this form. If I rewrite it, I have 3 squared. Then here, this one comes first, which is 2 times 3 times 2 root 2. Then plus bracket 2 root 2 all squared. So I can factorize this comfortably. I have 3 plus 2 root 2 all squared. That is our root 2 plus 1 all raised to the power x. This is not in this form. Now we can still simplify or manipulate this expression on the right hand side further. 3 can be written as 2 plus 1, then plus 2 root 2 can be written as 2 times 1 times root 2. Let's remember there's a squared here. Root 2 times root 2 is 2. So I have root 2 all squared here, plus 1 squared, plus 2 times 1 times root 2. Let's remember there's a squared here. Now if we also check, it is now in this form, so I can factorize easily. I will take root 2 out, then plus, here becomes 1, then square it. This square is now this one. So I have root 2 plus 1 raised to the power x. Good. Now, if I apply this law in indices, which is a raised to the power b times raised to the power c, it will give us a raised to the power bc here. I now have root 2 plus 1 all raised to power x is equal to root 2 plus 1 all raised to power 4. So this and this are the same. That means x is equal to 4 in case 1. So case 1 yields x is equal to 4. Now let us try for case 2. Now let us remember that root 2 plus 1 is the same thing as 1 over root 2 minus 1. So I'm going to rewrite this for this. So I have 1 over root 2 minus 1 all raised to power x is equal to, now this is 17 minus 12 root 2. Now rewriting this one, this is root 2 minus 1 all raised to power minus x is equal to 17 minus 12 root 2. If I manipulate this part of the equation, I'll have root 2 minus 1 all raised to power 4 is equal to root 2 minus 1 all raised to power minus x, just as we did in case 1. So we'll get root 2 minus 1 all raised to power 4 if we try the same thing for the second case. So this and this are the same. That means minus x is equal to 4 and x is equal to minus 4. So x is equal to 4 and x is equal to minus 4. Now let us see if this is the solution to the equation, which is root 2 plus 1 all raised to power x plus root 2 minus 1 all raised to power x is equal to 34. I'm going to put 4 where I see x and then solve it. So I have root 2 plus 1 all raised to power 4 plus root 2 minus 1 all raised to power 4 is equal to 34. We want to check if it is equal to 34. This and this will cancel out. This is 9 plus 8. Then plus 9 plus 8. Is it equal to 34? This is 17 plus 17 is 34. Yes. So 34 is equal to 34. Please like this video if you find it interesting. Subscribe to my channel if you haven't done so, and also share this video. I would like to read your comments in the comment section. Thanks for watching and see you in another video.